Since its discovery by the Atlas telescope in Chile on July 1, 2025, 3I Atlas, with its anomalous behavior, has further strengthened our belief in alien civilizations. In the quest to find intelligent life beyond Earth, several scientific projects have actively sent messages into space announcing humanity's presence. However, the late Stephen Hawking famously warned against this approach. Why? Because history shows us a harsh truth. When advanced civilizations encounter less advanced ones, it rarely ends well for the less powerful. Hawking feared that any alien civilization able to cross interstellar distances would be far more technologically advanced than us. They might not view humanity as equals or friends. Instead, they could see us as a threat, or worse, a resource to be exploited. His advice was clear. Instead of broadcasting our location loudly across the stars, we should first listen quietly. The universe is vast and unknown, and until we truly understand who might be out there and what their intentions are, it's wiser to keep a low profile. This debate between curiosity and caution sets the stage for the mystery we're about to explore. 3I Atlas, the enigmatic visitor moving through our solar system, that may challenge everything we think we know about contact, caution, and the cosmic unknown. What sets 3I Atlas apart is its remarkable trajectory and incredible speed. It's moving at a staggering 137,000 miles per hour, and its path zooms it close enough to the Sun to swing around and then head inexorably back out into interstellar space. Its orbit is distinctly hyperbolic, a signature that it hails from beyond our solar system, making just a brief visit before disappearing again into the star-studded darkness. But beyond its staggering speed and interstellar trajectory, 3I Atlas has been baffling astronomers with a set of unusual behaviors that don't quite fit the mold of a typical comet. Usually, when a comet approaches the Sun, its tail streams outward, pushed back by solar radiation and solar wind, a glowing plume trailing away like a cosmic banner. Yet 3I Atlas breaks these rules. Its dust plume isn't streaming away from the Sun, it's stretching toward it, almost as if defying the laws of physics. This peculiar behavior immediately raised eyebrows in the astronomical community. Even more puzzling is the comet's brightness. Usually, comets shine brighter as they approach the Sun, their ice is vaporizing and feeding a fiery comet tail. But 3I Atlas doesn't follow that pattern. Instead of glowing more intensely, its brightness has actually faded as it's drawn nearer to the Sun, refusing to put on the dazzling show astronomers expect. One theory is that 3I Atlas might contain materials unlike anything we're familiar with, ingredients formed in the darkest corners of the galaxy, far from our comfortable solar neighborhood. To add to the mystery, when astronomers scanned 3I Atlas for the usual suspects, chemical signatures like cyanogen, diatomic carbon, and volatile gases, they found almost nothing. In its first days after discovery, the comet's spectrum was eerily blank, like staring into a fire that burns fiercely but leaves no smoke behind. Over the following months, as 3I Atlas edged closer to the Sun, a faint trace of cyanogen finally appeared. But even this trace refused to behave like the cyanogen signals we've seen from other comets in our solar system. With the dust sometimes pointing toward the Sun, near absence of typical gases, and sluggish, unconventional chemical changes playing out, 3I Atlas remains a cosmic enigma, something no one has yet cracked. NASA's James Webb Space Telescope chipped in with some of the sharpest infrared observations to date. It revealed that 3I Atlas has one of the highest ratios of carbon dioxide to water ever recorded in a comet, another oddity that suggests this visitor didn't form in our kind of stellar nursery. All these strange clues have scientists scratching their heads and reopening the door to extraordinary possibilities. Could it be a natural comet forged in alien star systems? Here's where Harvard astrophysicist Avi Loeb steps in to deepen the intrigue. Loeb, a figure known for his willingness to entertain unconventional ideas, proposed an extraordinary hypothesis. 3I Atlas might actually be an alien probe disguised or appearing as a comet. Loeb points to the object's unusual orbital path as a key piece of the puzzle. 3I Atlas approaches the inner solar system close to the orbital planes of Venus, Mars, and Jupiter, an exceptional alignment with a combined probability of just 0.005%. Such precision, he argues, might not be a mere coincidence, but could suggest a deliberate trajectory engineered to survey these planets. Furthermore, 3I Atlas achieves perihelion, the point closest to the Sun, on the opposite side from Earth. According to Loeb, this positioning could enable maneuvers shielded from our observation, perhaps to avoid detection while adjusting speed or course, reminiscent of a stealth spacecraft remaining hidden until ready to reveal itself. Avi Loeb is careful to clarify that this is largely a thought experiment. He acknowledges the dominant view within the scientific community that 3I Atlas is most likely a natural object, probably a comet with unusual traits. Yet he insists that considering alien technology as a viable hypothesis forces us to broaden our thinking and be open to surprises. His speculations lead to intriguing, if unsettling, questions. Could 3I Atlas be a scout, a probe dispatched by an extraterrestrial civilization to gather information about our planetary neighborhood? Could it be drawn here by signals we've sent into space, or is it passing through as part of a larger exploratory mission? While we have yet to detect any direct signs of artificial technology, no radio signals, no visual indications beyond subtle orbital anomalies, the mere presence of 3I Atlas in our system challenges us to reconsider the boundaries between natural celestial phenomena and possible evidence of extraterrestrial intelligence. This opinion fits perfectly with the dark forest view of the universe, a theory popularized by science fiction and considered seriously by some scientists today. The dark forest theory imagines the universe as a vast dark forest where every civilization is like a silent hunter trying to survive without revealing its presence. In this forest, making noise, such as broadcasting signals that show your exact location, risks attracting predators. Because resources in the universe are limited, and every advanced civilization faces potential threats, the safest strategy is to remain quiet and cautious. Or, worst case, if there's any risk that this newly discovered civilization might someday threaten your species' survival, the safest move is to eliminate that threat immediately. No negotiations, no second chances. Just shoot first, ask questions later. It's a brutal, preemptive defense strategy born from a place of deep uncertainty and existential fear. Think of it like the ultimate cosmic game of chess, only the stakes are unimaginably high. If you wait too long, that new player might develop weapons, technologies, or alliances that could wipe you out. But if you act too quickly, you might destroy a potential ally, or worse, commit an irreversible act of genocide on a civilization that meant no harm. This principle taps into the darkest parts of survival instinct, amplified to an interstellar scale. It raises huge ethical questions. Is it right to judge a civilization as a threat before we've even met them? Could mutual understanding and communication actually be possible? Or are we doomed to a preemptive war out of fear? As humanity rockets further into the cosmic arena, grappling with these questions might become more than science fiction. They could define our very future, our survival or extinction. So, what would you do if you were in command? Shoot first? Or try to talk? Let me know your take in the comments below. And as always, buckle up, because the space race isn't just about technology. It's about the fate of civilizations. Now that we understand the cold survival logic behind Stephen Hawking's warning and shoot first, ask questions later principle, let's examine the heated debate among scientists about what humanity should do next. On one side, there are those driven by curiosity and optimism. They argue that reaching out, actively sending signals into space, could lead to peaceful contact with other civilizations, exchanging knowledge, and expanding our understanding of the cosmos. To them, the reward of connection outweighs the risks, and humanity has a right to say hello to the universe. That's the reason why we have real historical examples of scientists boldly reaching out, by actively sending signals to space to announce Earth's presence. In 1962, the Evpatoria planetary radar in Crimea sent the Morse message, a series of short radio bursts encoded in Morse code, aimed at Venus to test interplanetary communication methods. The most famous early effort was the 1974 Arecibo message, a powerful binary-coded radio transmission sent from the Arecibo Observatory in Puerto Rico, aimed at the M13 star cluster about 25,000 light-years away, containing encoded information about humanity and Earth. The first organized SETI experiment, Project Ozma, 1960, conducted by Frank Drake, involved listening for signals from nearby stars, marking the start of coordinated attempts to communicate beyond Earth. Over decades, scientists have crafted increasingly sophisticated messages such as Linkos, a symbolic language designed by Hans Freudenthal to teach concepts to extraterrestrials, and initiated projects like Breakthrough Message to design messages for active transmission. Not to mention earlier visionary attempts date back to the 19th century, when mathematician Carl Friedrich Gauss proposed creating giant geometric shapes on Earth to signal extraterrestrials visually. But opposing this hopeful stance are the voices of caution, strongly influenced by Hawking's sober advice. They warn that revealing our location might be a fatal mistake. This concern is based on the very real risks illustrated by history. In fact, history provides sobering lessons about what can happen when a more advanced civilization encounters a less advanced one. Time and again, we've seen that these encounters rarely end peacefully for the less powerful. Take the example of European colonization in the Americas. Technological and military superiority enabled Europeans to dominate indigenous populations, leading to widespread violence, displacement, and catastrophic loss of life. This tragic chapter illustrates how advanced civilizations often view less advanced societies as obstacles, resources, or threats to be eliminated. Similar patterns appear across history, from the rise and fall of empires like the Khmer to mysterious collapses of civilizations, such as the Indus Valley, where environmental stress and conflict may have played a role. If we extrapolate this to the cosmos, it's not unreasonable to fear that any extraterrestrial civilization, with the capability to detect our signals, might see humanity in a similar light, as a potential threat or resource to be controlled or destroyed. This historical precedent strengthens Stephen Hawking's warnings against broadcasting our location to the stars. Imagine shouting out in the dark forest of the universe, who might be listening, and what might they want from us? It's a stark reminder. Caution is not paranoia, but a survival imperative.